Well, everybody, we've seen rational numbers. It is now time to see irrational numbers. So there's a definition here. They're numbers that cannot be written in the form a over b. A and b are just integers. It's impossible. They actually go on forever, but they never repeat. So before we take a look at them, let's review rational numbers. They're numbers that can be written in the form a over b. If you can see, the answers are all circled. -2 is 2, -2 over 1, and so on. 81 hundredths, 3/9, not 3/10. Talked about that mistake in class. If that bar isn't there, then it's 3/10. So mixed number, you have to make an improper fraction. Same with this decimal, it's like 2 steps. 5 9/10, and then multiply these two, 50 plus 9, 59. And I even threw in a square root. So that's rational, because the square root of 64 is 8, wearing its Halloween costume coming up. It's just 8 over 1. So you might be wondering, yeah, but what numbers are irrational? Oh, so funny you've asked that, because here are some examples of irrational numbers. First, pi. Yes, good old 3.14, which is only an estimate, everyone. And by the way, pi is spelled P-I. It's a Greek letter. It's not P-I-E. So anyhow, that goes on forever. That's 3.14159. It just keeps tumbling away into infinity. It never repeats and it never stops. So anything with pi being multiplied, added, any calculation with pi is irrational. Okay, now this is a square root, but compare it to this one. That one gave us a whole number. This gives us a whole lot of decimal numbers. So that is irrational. This number will never stop. It will never repeat. And one more, you get the idea. Some people will tell me it repeats because of those 5s. It is not a repeating decimal. So that's really it. Irrational numbers are pi and square roots that do not give you whole numbers. That's what you need to know. So our task is going to be to fill in boxes like this. So the real number system consists of rational numbers and irrational numbers. Now these are all the numbers from the front that I just showed you. These are all rational because I just wrote them as fractions. I cannot divide two whole numbers and have it go on forever and never repeat. When you divide two numbers, it either terminates or repeats, which kind of sounds like the title of the assignment before this one. Terminating and repeating decimals. So here's what we're going to do. We're going to attempt to place these numbers in the correct box. Okay? Normally, when I give this as a question or on a quiz, too many numbers are written over here. So let's just work our way across quickly. And this is it. It's a shorter video today. 2 and 183, it's not thousands, it's 999. I can write that if this pen would work. 2 and 183, 999. Now, I can make that an improper fraction. I'm not worried about what that is. That's not the goal here. The goal is to put the number in the right box. It's rational. That is a rational number. You're looking at a over b. Done. I just saw that one on the front. That's an 8. 8 is the same as 8 over 1. So the square root of 64 goes here. That can be made into an improper fraction. 14 plus 1, 15/7, right? See, most of what we work with our whole lives are rational numbers. We don't work with these very often. But 0.75, oh wait, we don't call it that. 75 hundredths. That can be written in the form a over b. Square root of 10. Oh wait, what is the square root of 10? If you put it in a calculator, you will see a number that goes on forever and never repeats. I know you see these 2s, 7s, and 6s. It does not. It's going to keep changing as you go to the right. The square root of 10 goes over here. -12, well, that's just a -12 over 1, right? There it is. Again, I don't have to write them as a over b. Those aren't the directions. 2 pi. Any calculation with pi goes here. Yes, that is 3/9, not 3/10. Last one, 2/9. Well, that looks like it's already in the form a over b. So you take a look at this visual, everyone. The only thing that goes over here, calculations with pi, and square roots that do not give you whole numbers. Everything else is rational. I always give this question on a quiz. It's worth 10 points. I put 10 numbers down here. Almost always too many numbers over here. People put repeating decimals here. No, I can write that as a fraction very easily. That's what you need to know. Let me show you the assignments. What I just showed you. You will put some numbers in the correct boxes. Some of those numbers look the same. I might have to change them now. Write these in the form A over B. We still want to keep practicing that. And down here, I did one for you. You will have to say, first of all, divide, make it a decimal, and tell me if it terminates or repeats. This terminated because in a calculator, if I do 5 divided by 16, this is what it looks like. See how it stops? That means it terminates. Okay, you will be able to tell in a calculator if it terminates or repeats. Not a real long assignment, maybe 10 to 15 minutes. So try to get it done. If you have any questions, as always, you know what to do. Reach out to your math teacher. See ya.